In this video, we shall study the addition and subtraction of repeating or recurring decimals. This video is part 1. We shall study addition and subtraction with pure repeating decimal numbers. In part 2, we shall study mixed repeating decimal numbers. In this explanation, we are not employing the method about converting repeating decimals to fractions. We are studying an alternative method, known as the fit method.
What is it about?
Let us know it with a few examples. Let us consider the addition 1.98 repeating plus 2.75 repeating. We are adding these numbers in the usual way. Draw a line. Can you tell me how many digits have got the sum as repetants?
2.
2 digits, very good. We shall discuss later why we want to know this. Let's continue. 8 plus 5.
13.
The one of the 13 is a carry, or carryover, which moves to the next column just like in an ordinary addition. Let's continue. 9 plus 7.
16.
Plus 1 of carry.
17.
Again, the one of the 17 moves to the next column. The decimal point is located at the same position of the summand. 1 plus 2.
3.
Plus 1 of carry.
4.
The sum will also be a repeating decimal number. But well, the addition is not done yet. Those who try to add these numbers with the traditional method, which is about converting the decimal numbers to fractions, may notice this is not the final result. There is something missing. Let us know the fit method, taking notice of the first digits of the sum's repetants. In this case, 9 and 7. Let us add them. 9 plus 7.
16.
16 is greater than 9. Whenever this happens, that is to say, the addition of the first digits be greater than 9, we shall make a fit.
How do you make it a fit?
Good question. How many digits you told me the summons repetant have?
2.
2, right. Thus we shall write 2 zeros and a 1. Draw a decimal point, a vinculum, which is the bar drawn of the repetant, and send it to be added with the previous result. This addition is pretty easy. How much is it?
4.74 repeating.
Which is the same as 4.74, 74, etc. This is the correct answer. Those who try to use the method about converting repeating numbers to fractions will notice the answer is the same. As a rule of thumb, we shall make the fit whenever the sum of the first digits be greater than 9. It's easy, isn't it?
Yes.
Let us see another example. Let us consider the addition 3.781 plus 0.292. Again, we shall add in the usual way. How many digits in the sum as repetants?
3.
3 digits, right. 1 plus 2.
3.
8 plus 9.
17.
The 1 is again the carry. 7 plus 2.
9.
Plus 1 of carry.
10.
The 1 moves to the next column. The decimal point must be aligned with the other 2 again. 1 plus 3 plus 0.
4.
The result will also be a repeating decimal number. Let us verify if we have to make a fit checking the first digits. In this case, 7 and 2. Let's add them. 7 plus 2.
9.
9 is not greater than 9. Thus, the right thing to do is to check the second digits. In this case, 8 and 9. Let's see. 8 plus 9.
17.
17 is indeed greater than 9. We'll make a fit. How many digits has got the repetant?
3.
Thus, we shall draw 3 zeros and a 1. Decimal point, vinculum, and add it to the previous result. How much is it?
4.074 repeating.
This is the same as 4.074074, and so on. Now the addition is complete. The general rules will be, if the sum of the first digits in the repetants equals 9, we have to try a sum with the second digits. If the sum is greater than 9, we have to make a fit.
Professor, what if the sum of the second digits equals 9 as well?
Simple. We shall check the sum of the third digits to be greater than 9, and so on. If in any of the columns the sum is greater than 9, we have to make no fit. Let us try another case. If we consider 1.45 plus 2.37, it would be 5 plus 7.
12.
The 1 moves to the next column. 4 plus 3.
7.
Plus 1.
8.
Recall the decimal point. 1 plus 2.
3.
The result is always a repeating decimal number. If we check the sum of the first digits, 4 plus 3,
7.
7 is not greater than 9. Thus, 3.82 is the final result. Now we are using the fifth method on subtraction. Let us consider, for instance, 1.27 minus 0.65. As well as the addition, we shall subtract in the usual manner. How many digits in the repetance?
2.
2. Let us begin. 7 minus 5.
2.
1.2 minus 0.6 equals 0.6. 0.62 repeating. Let us learn how to make the fit in subtractions. Let us begin with the first digits, in this example 2 and 6. Now we are going to subtract instead of add. 2 minus 6.
Negative 4.
Negative 4 is less than 0. Whenever the difference between the first digits of both repetants be less than 0, we make a fit. Since we had 2 digits in the repetant, 2 zeros we shall drop. Add a 1, just like in an addition. Write the decimal point, a vinculum, and move it to be not added but subtracted to the previous result. How much is it?
0.61 repeating.
Which is 0.61, 61, etc. This is the final result. Let's see the general rules. We shall make a fit if the difference between the first digits is less than 0. Pretty simple, isn't it?
Yes.
Let us see another example. 3.385 repeating minus 0.392. In this case, the repetant has got 3 digits. 5 minus 2.
3.
8 minus 9 equals 9, subtracting 1 in the next digit of the minuend. Thus, 3 minus 3 minus 1.
9. Subtracting 1 in the next digit.
Good. 3 minus 0 minus 1.
2.
Let us check the fit subtracting the first digits. In this case, 3 and 3. 3 minus 3.
0.
If the subtraction is 0, which only happens when the digits are equal, we shall check the second digits. In this case, 8 and 9. 8 minus 9.
Negative 1.
Negative 1 is less than 0. Since there are 3 digits in the repetant, we draw 3 zeros and a 1. A decimal point, vinculum, and subtract to the previous result. How much is it?
2.992 repeating.
Which is 2.992992, etc. This is the final result. Let us note the general rules. If the subtraction of the first digits equals 0, we need to check that the subtraction of the second digits is less than 0. If the subtraction of the second digits happens to be 0 as well, we need to check the third digits to be less than 0, and so on, in case of more digits. If any of the differences is less than 0, we shall make no fit at all. Let's see. 6.98 minus 4.12. This is 8 minus 2.
6.
9 minus 1.
8.
6 minus 4.
2.
The result is also a repeating decimal number. Let us check the first digits. 9 minus 1.
8.
8 is not less than 0. Then the final result is 2.86 repeating. What happens when you want to add or subtract two repeating decimal numbers with repetants of different length? Let's see an example. If you want to add 19.878 repeating plus 4.2 repeating, you may notice that one of them, 4.2 repeating, has got a single digit repetant. If you consider 4.2 repeating as 4.222 repeating, you may regroup the repetance digit without changing the quantity. Anyway, it doesn't matter how many digits you group in the repetant. There are infinite digits to take from. 4.2 repeating is the same as 4.222 repeating. You may now add this way. If there exist numbers with different repetant lengths with more than one digit, you must find the least common multiple of the numbers of digits the repetants have. For this example, 2.375 has got 3 digits and 4.48 has got 2. The least common multiple of 2 and 3 is 6. Thus, the addition would be made with 6 digits in the repetant.